Thank you for that introduction. Thank you all for coming and listening to me talk for a little bit. I'm really grateful to have the opportunity to come and talk about trying to deliver ecological forecasting models for decision makers. As Corinne mentioned, this is supposed to be a shared presentation, so it's going to be kind of split into two halves where I'll be giving both Colin's part and then also my own. And we'll be talking a little bit about, or rather I will be talking a little bit about all of the different things that you can do to try and help improve the way you deliver something to a decision maker. So a little bit of our background. So we're a company called Apex RMS. Before that, I was in academia for a long time. I did a couple postdocs, including here at U of T. But now I am working as a data scientist at Apex. Colin, who is the president of Apex, he has been in the whole delivering forecasting models for probably more than 20 years. It originally started working with a different company, and then he decided to work on his own. Then he started Apex. And then in the last about 5 years, we've started kind of taking off in terms of as a company, where we keep growing, and we've been adding about 2 to 3 new employees every year. So although we're still a small kind of Canadian company, we are kind of growing rapidly, and it's all in this umbrella of trying to deliver ecological forecasting models to different folks in and around. So when I talk to you about different folks, the folks that I'm talking about tend to be government organizations. So you can imagine most of our clients actually tend to be American clients. So you're talking about USGS, like the BLM, US Forestry Service. We also do Canadian Forestry Service, a lot of different Canadian organizations like ECCC. We also work with provincial governments. We work with nonprofit NGOs. So you're looking at like the nature conservancies, like the different organizations such as that. And even more recently, we started working a lot with different types of indigenous communities, all trying to get different complex scientific models into the hands of the people that are more kind of boots on the ground or policy in positions of making policy changes. So that's a little bit about who we are and how we got here. And so when we have this thought of how to try and deliver things in a way that can actually be perceived. And one of the big ones is it needs to be actionable. And by actionable, we mean that you can actually deliver this information in a way that it can actually inform a decision. Because if it's too cryptic, if it's too complicated, if it's too advanced in certain ways, it won't be in a format that could actually be used, and it can't actually be actionable. And so there's this thought of like, if a tree falls in a forest, does it make a sound? We have this thought of like, if you have this model that's fantastic, it's great, it's the next best thing, but if nobody uses it, is it really a good model in the end? And so trying to do that translation of bringing it from just being an awesome model to actually being used is kind of our whole thing. So there's a lot of different examples of this. So you have some we've done, although there's lots of examples for different organizations, but you have ones that include, say, land management approvals. So you work with governments to approve different types of purchases or restoration projects or conservation projects. There's also things like forecasting models for vaccines with respect to both procurement and then also efficacy. We have things such as when you're talking about more regional or municipal, like policy planning in terms of city planning, urban planning, the amount of green space that needs to be provided, what is an adequate amount of resources or facilities associated with it. NGOs are interested, at least the ones that we work with tend to be associated a lot with like conservation aspects, like how can they share with their stakeholders that they managed to protect X number of species or this much area. So trying to quantify those numbers, trying to put value to all of that. And then also things with industry in terms of compliance, trying to have reclamation efforts or mitigation efforts after that. So all these are different ways in which you're trying to communicate this information to different types of decision makers. And when it comes to this decision-making process, I think a lot of folks kind of envision it kind of like this, where it's like you as the research scientist, and then the next step is the decision maker. So the decision maker being the person who's going to take your forecast, run with it, start invoking policies left, right, and center all over the place. But that does happen, but it's actually pretty rare. What it tends to look, there's a few usually layers in between. So the first layer that's most common is some form of analyst. And this is really all an element of trust. And if you were to take your model, no matter how well you present it, no matter how well you translate it, if you give it to someone who's in a position to make a policy change, they're going to want essentially like a second opinion, or someone that they trust that they can refer to and that can review the information and can kind of give their opinion of like whether or not we should trust this. So usually within the same agency, you'll have kind of two different groups. So then when I say decision makers, I don't mean like a single individual. It rarely is. It's typically a committee or a few different folks. So your decision maker is, say, 2 to 3 different people. You have your analyst, which may be one person, but may also be a different group of people. And then even in some different layers, you also have a third layer where you also have another research scientist. So there's kind of these different ways of communicating down the pipes. And as you, the research scientist, it's kind of your responsibility to communicate to all of these folks. So you're not just sending something straight to the decision maker, like some technical report that they can quite easily understand. You also need to kind of communicate with these other branches as well, typically. And so that means providing the same material in these different types of deliverables. I'll talk a little bit more about what that might look like a little bit later. But it's just kind of an important concept that usually you're not kind of 1v1 with your decision maker. There's kind of more of a network of folks that are involved. And trying to communicate to that network of folks is really important, which requires you to tailor your message a little bit each time. So yeah, typically in our experience, we're rarely kind of doing this. It's usually some intermediary, and it's more of kind of an ongoing interactive process. So I wanted to ask a question for you folks. So just take a minute to kind of think to yourselves, what do you think you can do to get decision makers to essentially act on your forecasts? Like, how can you convince these folks within this pipeline to actually take something that you've come up with, to trust what you've come up with, and kind of work on it? So just think about it for a few minutes, and then, or let's say 2 minutes, and then I'm going to come back and see if anyone has any ideas. All right, does anyone have an idea of how you might enable a decision maker or someone within this pipeline to act on something that you have? Yes.
Present alternatives.
Yes, presenting more, yeah? Absolutely, yeah. So presenting alternatives, not having a single, you should do this, it really helps build essentially options for the client or the decision maker who's trying to do something. Any other ideas? Yeah.
Have to make sure they're okay with something.
Yes, so to actually kind of both listen to what they want, so deliver kind of what they're looking for and not kind of go off on your own, and we'll talk a little bit about that as well, but also making sure that you satisfy the requirements and not kind of fall short or do only partially what they're looking for. One more? Yep. Yes, so kind of whole communicating in terms of translating it into a way. And when I say translating, I also want to emphasize it's not like dumbing down. Like you're not trying to present these models like to the layman, let's say. It's just kind of communicating in a different way that can be more received by your target audience. And when it comes to target audiences, there's a lot going on in terms of you really having to think of who is my target audience and how can I deliver for them. We'll talk a little bit about that as well. But first, I just wanted to kind of get at this first element is that for someone to act, the big thing that they need is trust. If they don't trust you, it's all kind of falls apart. It doesn't matter how good you are or what other characteristic you might have. If they don't trust, then it doesn't really lead to anything. So how do you get them to trust you? Like, what is trust in the aspect of an ecological forecast? Well, there's this equation that gets kind of thrown around a lot in our company, and it's this equation that we try and assess trust. And so obviously it's not like quantifiable numbers, but the elements of it are essentially what makes a relationship exist between one person and the decision maker. So the first one is credibility. And I think most folks in this room, or almost all these folks in the room, are going to pretty much satisfy this. Credibility is the aspect of like essentially intellect or capacity or ability to conduct the models. And most people are able to do that. Most people are smart and they have the models. And there are some people that are, let's say, a little bit more technically competent than others. But overall, credibility in terms of having technical expertise is the easiest one to satisfy, because you are a scientist, you have the knowledge, you are a technical expert, probably one of the most advanced experts in your area. It's really unlikely for you to be kind of trailing behind that. So it's really the other elements of this equation that are really important for us to focus on. And the next one is reliability, and that's with respect to being consistent, being able to respond if people reach out to you, being able to like essentially respond quickly, dependability in terms of asking a requirement of someone, them actually being able to produce something for them, that they can rely on you, that they can come back to you a year from now, you'll still be around to actually kind of field their questions or respond to their questions. That's kind of where that reliability element comes in. Intimacy is really kind of this element of risk. These organizations, when they're trying to work with you or trying to collaborate with forecasting models, they're taking a risk. They're investing tens, hundreds of thousands of dollars on you. Sure, the organization might be a big organization, like Imagine Environment Canada or what have you, but the person that's actually reaching out to you and trying to procure your forecasting models, that is not a big organization. That's a single individual whose budget might be only 50 grand a year. So they're entrusting you with like half of their budget or more, and they have to sell that to their boss, and they have to convince other people, or like even in some cases taxpayers, that this is a good decision to make. So they're taking a risk by entrusting you with their money, and so you need to try and take that risk. And it doesn't even necessarily need to be money. It just needs to be like, we're going with this group. You need to try and build that intimacy, try and satisfy that this risk is going to be well suited, that it's going to kind of translate into something, and that you are also taking a risk on this by kind of working on this project with them. You're kind of this mutual intimacy that you're trying to build with the person so that they trust you a little bit more. And the last one's self-orientation, which is kind of your essentially selfishness or wanting to do things kind of your own way. The biggest kind of thing there tends to be perfectionism. So you have folks that are interested in the best model. And the best model is a good thing to try and go for, but sometimes the best model comes at a cost. And that cost tends to be time. And when you have a client who has X amount of time to try and do something, you have the government that only has 100 grand to do whatever. If you blow all that money trying to get something, and in the end you're not able to produce something, you're kind of pooched, and you've ruined the relationship with that client, and therefore trust has been eroded. So usually these four things that all kind of build together in terms of building trust, building a relationship with a client, in this case building or convincing a decision maker to kind of take your forecasting model and actually apply it. So your first step really is identifying your audience, because it is important to identify the audience. So are you connecting with your research scientist, analyst, decision maker? Are you going through all of them? In which case you need to kind of tailor your message each way. And then how do you gain the trust of each of these different types of individuals? Those are all kind of the questions that we think about all the time when we're trying to either first build a relationship or kind of maintain a relationship with some form of decision maker, so that they keep coming back, so that they're encouraged to continue to use it. And most importantly, they're actually take what we've done and actually act on it. Because there are instances where everything gets lined up, you would produce something, they take it, they purchase the model, and then they don't actually act on it. And that's because somewhere along this pipeline, it's fallen apart. And our company has had experience, both positive and negative, kind of going through all of that. And we've come out about 15 or so years later with some experience behind it, some of that I'm trying to share with you, but we're not perfect either, and we're also still learning, and this is just a very ongoing dynamic thing that you need to build, basically case by case with every decision maker, every organization that you're collaborating with on an ongoing basis. So we talk about, there's essentially 4 elements of a actionable forecast. And so the first one is credibility. And for a forecast to be credibility, so right now I'm focusing less on kind of the relationship and more on the actual model itself. So the first one would be that it needs to have a track record of some sorts. So it has to have some history, either some peer-reviewed paper, some other examples of other organizations that have used it, just some form of past success or past validation that the organization might appreciate or might want to move on forward with. Also, as was mentioned, you want to acknowledge uncertainty. Nobody likes to have a single track, single observation. They want different options. They want to see what is the range of conditions, just because life is dynamic and it's really unlikely that the one thing you propose is exactly what's going to happen. So being able to assess some form of confidence, some uncertainty around it, providing different scenarios. So that's really popular in different types of climate modeling. So we're not saying in the future species will be gone with climate change. You're saying, well, under this carbon emissions and this carbon emissions, you'll see this. Using this GCM and this GCM, it'll be this. So you're providing a different range of conditions that all might be, all might occur as a result of this, not just a singular one. And then the last one is really an element of transparency. So being able to actually show as much as possible what you're actually doing. The more you're a black box, the more you erode trust, the harder it is for someone to take your model and kind of appreciate it. So you want to be as transparent as possible, and that means more than just kind of like sharing just an R script, because that ends up being fairly cryptic and potentially useless if you go as far down as the decision maker. So you're trying to make it as transparent as possible, but also that means kind of taking more of an active approach to trying to communicate to each of the people within that pipeline. And best available science. So I already talked a little bit about this, but not dumbing down the science. So you're still maintaining the science. None of this comes at the cost of making a simple, basic model. You don't just do a linear model because people might understand that easier. You still do the best science, but it's under this guise of making it transparent, adding uncertainty, and trying to satisfy the other requirements. The next is that it needs to be reliable. And when we talk about reliable, it means having consistent updates, so automatic updates. This is really popular for anything that's real-time monitoring. So we saw that with COVID. Anything that has to do with just kind of year-over-year assessments. So everyone's looking for yearly reports of how is this happening with this species, what's happening in this types of change, and so on, be able to say, hey, the change between last year and this year is this, which means updating the model. It's really important to have that level of reliability. Also, decision makers tend not to engage immediately. They might solicit your help and then months pass, and so you need to be able to update that information down the road, or maybe years pass, or maybe they come back to you 2 years later asking you to do it. So there is an element of reliability where the model can't be essentially frozen. It needs to consistently update or be able to be updated as time progresses. So that's really important. And a big portion of that is being available in the future. So I think this is part of the reason why a lot of decision makers struggle to say hire graduate students or with, or even say postdocs, and that's because they leave. They're gone 2 to 6 years later, and if they need to re-update the model, they might not be able to find that person. So being able to get to a group that is where it has get to a model where it's able to consistently be updated, or be presented with a model that they're able to update on their own is probably even better. It needs to be relevant, and that's trying to satisfy what the person wants, not necessarily what you think is best. So kind of an interesting thing that I recently learned is that Environment Canada actually has a rule where they can't say 50% rain. The forecast is either 60% rain or 40% rain. And the reason why they do that is because they don't want people to not be able to make a decision, because if it's 50-50 chance of rain, do you bring an umbrella, do you not bring an umbrella? So Environment Canada has this rule. Whether or not it's 50% doesn't matter. It's going to either be 60 or 40, so you have to make more of a lean in that way. And that if that's what the decision maker wants, that's what you got to produce. You don't just kind of go, well, 50% of what it is. I'm not going to budge on that. That's not what's wanted. And we can quibble a lot about different types of metrics. Like, for instance, COVID, we saw a number of hospitalizations was a really popular metric. You could argue whether or not that was a good metric or not, but that's the one that was particularly popular. And so trying to produce these models in a way that's actually what the decision maker wants is particularly important. So it needs to be to suit the decision maker, because for whatever reason, like, we don't know policy, we're scientists, they know the policy, they know how to deliver these types of things. And so it's really communicating with the decision maker to see what they need and trying to produce the model that satisfies that. And then don't limit things, don't pull back because you think, oh, that's not really informative, oh, you don't actually need all of this. Essentially trying to present the decision maker with more options typically is better than less, because you're eroding trust by thinking that they can't understand, or they don't need to have this information. It's not a great approach. It definitely kind of ruins the relationship. So building a model that essentially covers more as opposed to less tends to be preferred. And then the last one is accessibility. And that's really what format can the audience actually handle it. And this is more my area of expertise within the company. And it's because few people can actually just pick up an R script and run with it, or pick up a Python script and run with it. Even people that are designated as analysts or research scientists, even if they do know R and Python, they're not going to spend an afternoon trying to kind of spin up your R script, troubleshoot things that might go wrong, and have to reach out to you no matter how good yours is. They want something that's very accessible because they just don't have the time. So trying to produce products that exist in more than one medium, it can be an R script because you want to have that element of transparency, or a Python script, but it also should probably be other things. And so you can make a desktop application, you can make a web application, like popular example would be something like Shiny. There's lots of different ways to try and deliver products to people that exist beyond a massive notepad document. And delivery also depends on the audience. And so I talked a lot about having these models that can be easily and dynamically updated, and I'll talk more even about that. But sometimes audiences just want a single report because that's the way they're able to communicate to their decision makers, or to whoever their kind of audience is. And so you might have a static report. That report might get changed year over year. But that's those are just different types of versions of what you might example. So you might get your R script for one audience, you might get your web application for a different audience, let's say an analyst, and then you might get your static report that ends up being in the hands of someone who's in a policy decision. So online dashboards are pretty popular. That might be someone who's like technically competent, but not in the weeds enough to start drafting up R scripts. And then there's even things like interactive apps, essentially what I've already been chatting a little bit about. And ideally, these forecasts are for multiple audiences. Kind of like I mentioned, you're not just sending one thing to one person. Because there's other folks in the pipeline, it's more common for you to send different mediums of essentially the same model. So to summarize, your decision makers depend on you, and they do it through trust. And if there's no trust, then there's no relationship, and therefore you don't have a decision maker. Gaining trust is absolutely key to actually making that model both actionable. So it goes beyond just, I've secured this person to work with me. It goes to the point of, this person's going to take what I've worked with them on and actually apply it. And to get that trusted model, the model where someone's going to take it and actually start running with it, then that's where you start invoking things like credibility, reliability, relevance, and accessibility. And getting all of this is very difficult. So as much as you can, try and learn from other folks, such as ourselves, or other groups of organizations that are out there, or some form of mentor, just because it's very nuanced. There's a lot of things that won't just be covered within the hour that we have together. So it's good to have someone coach you along there. So Q, that's section 1. Section 2, I'm going to get into more of the specifics of how you actually go about executing that. So providing models. how do we actually go into what are the specifics more so of a model? To reiterate, these are the 4 things: credibility, reliability, relevance, and accessibility. I'll be repeating them quite a lot, so just get used to that, I guess. And then importantly, identify your audience as you're working through it. So the example I'm going to kind of work through is that of a species distribution model. These are really popular for ministry services, so like the Ministry of Environment, or whatever the acronym is these days. The Environment Canada, so UCCC, a lot of US organizations, including ones that I'll talk about that we worked with. And it's really like, if you have a species, where will it be in 3 or 4 decades? And that's a very common question that folks ask because they're interested in who's going to be moving into the area that I am, who is going to be leaving the area that I'm in. Am I going to get invasive species coming here, kind of damaging everything? Am I going to get my endangered species? Are they going to become extinct because they have nowhere else to go? Is there a mountain range in the way that they can't move to? Lots and lots of questions, and they all start with, where's the species going to be? And so that's a lot of how these species distribution models kind of get started. And so to give an example of one of them, here are 2 butterfly populations, how they're going to be moving throughout in the future. So the orange here is where they're going to be lost, the black is where their current range is, and then the blue is where they're going to be moving into the future. So you have this species, this butterfly species on the left, where in basically Central Valley, California, it's going to become practically extinct, but it's going to be quite a lot further north in terms of migrating into the Rockies. Similarly, the species on the right seems to be losing a lot of range in terms of the southern Rockies, but then increasing range into the northern Rockies, including the Yukon and Alaska. Now, these models are really just kind of, this model specifically actually is just climate only. So there's a lot going on here that goes beyond that. And it could be anything, but not to get too deep into the weeds of the science behind it, but essentially it means that when we're trying to present these models, you're trying to share different versions of it. And I'll get into one big way you want to show different versions is that of different scenarios. So we talked a little bit about different scenarios. And this is one example of presenting a different scenario. So we have 2 different climate projections based on global circulation models. So we have on the left, what would happen if it becomes drier, which is actually one possibility for the West Coast. And the other one is what happens if there's a bit of warming, but actually more variable precipitation. So some years wet, some years dry. That's another one of the common projections for the usual global circulation models. And then under 3 different carbon emission scenarios. Again, trying to present these changes that might be happening in more than one kind of static, this is the change, presenting it as some degree of uncertainty where if it gets warmer, this will happen. If it gets drier, this will happen. So this typically gets done using species distribution models. So there's a lot of different examples of them, but the stages tend to be quite similar. So you have some form of data curation stage where you're curating lots of points or observations for your particular species. You have some spatial processing stage where you're analyzing a lot of the climate variables. You have that modeling stage where you're doing your forecasting. And then importantly, this gets kind of rinse, repeat over and over again for lots of different scenarios. Again, global circulation models, carbon emissions, what have you, different land covers, all different possibilities. So the most common way of doing this is a software called Maxent. It's an old Java program that was made, I think, in 2006. This is what it looks like. It's fine, I guess. It's just kind of clunky in terms of the way it runs, and it produces these kind of HTML report outputs. So it's not particularly great for trying to share with folks because having an HTML as your report isn't great. So it certainly satisfies the element of credibility. This is probably the most popular species distribution modeling method around that I can think of. So it's credible. Lots of research around it, lots of papers around it. It's reliable in that it can essentially be reproduced, but it's not technically relevant because the delivery of it isn't great. It doesn't produce it in a way that perhaps can be taken by a decision maker, and it's certainly not accessible. So a technical expert needs to know how to use this. They need to know what levers to pull here, what buttons to click. You're not going to be handing this off to someone that has no knowledge of the species distribution models. And at the same time, it's going to be really hard for someone to trust the model outputs on the right-hand side because that document itself is fairly cryptic. All it has is really a map. That's something that they can appreciate. But the rest of the files that are kind of embedded in HTML, such as like ROC curves, AUC values, those are not going to kind of communicate quite well. And there's an element of reproducibility here that gets lost, right? Like if you want to rerun this again, you have to re-click through everything. So that's not going to fly well, even to someone who's another research scientist. You'd have to create this whole document explaining how to use it. Not very appealing. It's not going to probably go over very well. The next most popular, I would say, would be something like random forest. Also really good for species modeling. The only way to do it is through some form of programming language. So R and Python are probably the more popular ones. I think there's also a Julia version of it. Same deal though. It's credible. Lots of folks love random forest, lots of papers on about it. It's reliable. Again, not relevant and not accessible, pretty much for the same reasons as before. Slightly even more challenging because it doesn't even have a graphical user interface. So you're really just kind of telling someone, here's an R script, go for it. And maybe a research scientist would be able to pick up on it, but other folks would not. And so that's kind of a massive limitation of trying to share this. So what do you do? So when it comes to trying to deliver species distribution models, if you're kind of looking at the state of where it's at currently, there's no shortage of good models. Like I talked about two, but there's GAMs, there's GLMs, like logistic regression. You can even do ARIMA models. Like I can go on and on and on about 10 to 20 amazing, high-powered, tailored specific versions of species distribution models that exist with lots of literature to support them. But in terms of whether or not they're reliable, some of them are. Some of them can be kind of updated very easily in terms of just kind of rerunning it with new data, but it is a little clunky. You kind of have to go through the motions all over again. And something like that Java program that I showed at the beginning, that means re-clicking through all the buttons. Even just like a computer restart can set you back quite a bit. Relevancy, so you want to be able to deliver models, not reports. And those things are essentially the two ends of the spectrum. You either have the very beginnings of the model, where someone would have to start from scratch essentially to kind of chug through it, or you have the report, which is fairly static, which maybe is useful, but needs to be kind of tailor adjusted for the client. You kind of want something in between where the person who's on the other end, the analyst, the research scientist, they're able to run it with relative ease without having to work too hard. And that kind of leans into this whole element of accessibility where it actually needs to be digestible, where someone needs to be able to actually take it and understand what's going on. So a tale of three max-end models. So we have our stats version of it, so eval, sorry. You have maxent with the Java program, and then you have this custom Shiny application. These are all different ways of doing the exact same thing. I've used all three of them, and they all do basically all the species modeling characteristics you would want, but there's obviously differences among these three. So I want you to take a minute, maybe communicate with the person next to you, tell me what are perhaps some of the pros and cons of each of these, and who do you think is the intended audience? So I'm going to give you another 2 minutes, chat with your neighbor. We'll come back. All right, bring it back in. So we'll try to walk through a little bit of it. Like let's start with the R version. Does anyone have any pros, cons, intended audience of using it? Yeah, exactly. Yeah. Yep.
Like, I feel like it will be a good tool for another research scientist, because it's like, I mean, at some point, like something that can be very similar to others, but not like similar to others.
Yep. Yeah, that's spot on. So research scientist, it is a little more technical, so there's kind of a con there in terms of its accessibility. Any pros at least? Anyone good things to say about R? Yeah.
Maybe in serial analysis, so you want to do the same barcode so that the output and another input things, it's all in the same structure.
Great point. So the pipelining capabilities of R are quite good. So these other two programs, Maxent and the Java version and the Shiny application, their role is to do Maxent. But maybe you need to do something before in terms of curating the data or collecting the data. Maybe you need to do something afterwards where you've done this, now you need to run it into some landscape model or afterwards. Having it all kind of within the R environment might be really good to satisfy that requirements, and that might be what's required for the person that you're trying to build this ecological forecasting model. It's potentially less likely if you're communicating with decision maker because they're interested in essentially an answer, not to continue working on it. But there is certainly a market for this type for being able to produce this and share this with some form of clients. Does anyone see a pro, con, or audience for the Java version? Yep.
Well, when a student don't know anything, to have all the force them to learn methods.
Yeah, certainly an educational piece. It could potentially both, not just necessarily for students, but also for your clients. It kind of gets some familiarity with it because they're able to kind of click through, see what the model is even doing, kind of removing that element of a black box, add some element of transparency to what you're doing because it's easy to move things and click things and run quite quickly, and you can get up and started quite well. And it could even be approached for an analyst where you can kind of try and share something with them. You wouldn't commonly or probably ever deliver something like this to your clients because you're just giving them another piece of software. It'd be like saying go online and click on this. But essentially there is some utility of it in terms of trying at least as an educational tool. And then finally, the Shiny app. Audience pros, cons? Oh, sorry. All right.
You can make it as simple or complicated as you want based on
Yeah, so I think that's both a pro and a con, being able to make it however you want, because in some ways it's good because you're trying to simplify it, trying to make it focus the attention, abstract them a little bit from the complexities of it and really narrow in the user to only use A, B, and C and what are the decisions for that. But it's also a con because now you're kind of putting stuff behind a veil. You're preventing them from being able to have access to some features, and those features might be things that are really important for them. Do you have a comment as well? User-friendly, absolutely. So like most people can get behind this. Like if you see, you can just kind of click around along the top as a workflow. You can go from step 1 to step 2. You just click, click, click. You click, click, click on the left side. Really intuitive. It's certainly a step up even from this, where it's kind of hard to know where to get started. And being able to present these models in a certain way, in a way that's digestible, or where you can interact with it, is really important. So those are all great. Oh, sorry, one more. Yeah. Yeah. Yes, that's an excellent point. So you also have essentially two deliverables when you deliver something like a Shiny app, right? Because you have your interactive thing who might be more preferred for an analyst, and you also have the underlying RStats code, which someone like a research scientist, someone more familiar with, can kind of take with, customize it a little bit more, add the additional feature that might have been missing when you first designed it. Excellent point. So I'm going to talk a little bit about our approach to doing this, and it's through our own software. Not that our software is perfect, it's just something that we do, and so it's kind of the way we think about doing these types of models. And it's a software called Synchrosim, and it's a desktop application that does essentially what I've been trying to talk about for the last little while. So it automatically structures your data, so you have, instead of having to kind of read in raster files and all of those things, it kind of collates all that information for you. It allows for model pipelining. So if you do have a single species distribution model that you want to do, you can do that. But if you want to add to it, like some pre-steps, such as spatial processing to clearing up the spatial data, or if you want to do stuff after where you're trying to visualize it in a different way, those are also all possible. It allows interfaces with a lot of other different programming languages. So kind of getting at this other deliverables. So you're providing our products. You can be providing a Python script. We even have support now for Julia. We also include, I mentioned the desktop application, but we're building out a web application as well, essentially a Shiny equivalent of it so that folks can be able to use it there. Supports these programming languages, C# as well, and multi-processing. So that's really an important thing for a lot of decision makers. Perhaps one that gets a little bit more overlooked in academia, just because we have access to things like Compute Canada or some other supercomputer where that doesn't matter. But when you're talking about an organization that needs to run something at a 30 by 30 meter scale, they'd end up spending $10,000 with Amazon Web Services very easily. So you want to try and do stuff that makes it more efficient, faster, cheaper for them, because nobody is going to be able to spend that much money on computing resources. So we try to have different deliverables for different audiences, and our software is able to essentially try and satisfy that. So we usually do it in two very common ways of delivering our information. So the first one is a Synchrosim package, which is very similar to that of, let's say, an R package or a Python package, or Python library, sorry. So you have, it's a template for running your forecasting models. If you're designing the package, you're telling what is going to be represented in the model. Whether or not you want it to have years, whether or not you want it to have some form of validation step, or how many samples to kind of iterate through. You would do this when you're trying to create a new model from scratch when one doesn't already exist. We do have a suite of models that we have packages for, but if you're trying to create your own, that would be possible. It's very customizable. The interface is customizable in terms of what you see, what you put in. And the target audience there typically ends up being research scientists, ones that want to go create their own models, but they don't want to create the interface to actually kind of get started with it. And then the second product that we tend to deliver is out of a Synchrosim library. So these are a series of different types of models. So the models are already produced, and these are more for the analyst and the decision maker. There's already a package that exists, so everything is more or less set up in terms of what does the interface look like, both for inputs and outputs. What are they able to change? But what they're able to change gives them some power in terms of, okay, I want to run the model again, but I want to try with a different climate scenario. I want to run the model again, but I want to try random forest instead of max sense. We give them that power, but whether or not those end up in the first pass ends up being whether or not it's a package or not. So this is two different clients that have used this exact model for a species distribution model. So we have the USGS in the United States. They were interested in creating essentially a package that does species distribution models. So their requirements when they reached out to us was that needed a flexible model for doing species distribution models, one that could do GLMs, max sense, random forest. They needed one that they could specify with custom model settings. They wanted some form of pre-data cleaning, pre-processing, also some post-data validation as well. And the target audience there were research scientists. They were interested in running these models on their own. They just needed an interface to work with. On the other side of that, we had the Credit Valley Conservation, so organization a little west of here for Mississauga, Brampton, and Caledon. And their requirement was they need to run a bunch of species models. So they don't need to design a package in that, they just need them already essentially run. And so that's when a library is essentially more relevant for them. So trying to create something where they can have control over the model settings to change between different modeling scenarios or climate scenarios, but they don't actually need to make the decision of whether or not to include, let's say, random forests. That's not what they were interested in. And in that case, the audience there was an analyst and then inevitably a decision maker. So we're collaborating closely with the analyst because that's our intermediary, but then that's going to get passed up the pipe and then kind of invoke how is the Credit Valley going to manage the green spaces within those 3 cities in the next few decades. So when it comes to creating a package, the way we try and do that is learn from the client what are the different types of controls that they have. So we have something like they want some time steps involved, they want some iterations involved, and so you're kind of spelling out what are all the different variables that they need into essentially a large spreadsheet. That gets built into some form of graphical interface. So we go from having a spreadsheet of all the different requirements that they might need into some form of GUI where they have those options available to them to then change. So this process is what we would work with the USGS to essentially first define what this table looks like so that the interface looks exactly the way they want when it comes to modeling time. And in the end, it did have these 6 different types of pipelines that we inevitably built out. So each of these has an associated tab, and it includes things like the data preparation, the spatial, both spatial and non-spatial, which model to run, and then actually applying the model in the end. So that was kind of the building process. I'm not going to go through all the weeds of what went into each of these models, but that was kind of essentially the building process of first figuring out what are all the things they want to see in their graphical user interface, building out that graphical user interface, and then kind of working with them to try and pipeline all of that together so that it actually does what it wants to do. And the underlying code behind all this, although it looks essentially like a Windows application, is all actually R-based. So we're using R, and we can share with them the R script in the end, but it's all built on top of an R script, so it's familiarity with the client, but it's in a more interactive, very customizable way that the user can actually kind of walk through in an easy way. Now for our other client, the Credit Valley, then they're on the other side of it. So they're actually using the model. In that case, they're less interested in what are the inputs and outputs. That's already been done for them. They're interested in how do I change these variables? This time I want temperature instead of precipitation, or they edit all of the climate variables, and then they get presented with model outputs on the right-hand side. And the good part about all of this is that they've been streamlined a little bit into picking the ones that are most relevant for them. And it's not necessarily a full dichotomy. Like if we had, for instance, the CVC saying, oh, it'd be really good if we had this extra control, that's something we can do. So it's not that like the whole package design is essentially locked away and they're not able to change it going forward. But it does kind of at least start the conversation in a particular way where we can customize it for a particular client, make as much available to them as possible, and then present them with all of the run models that the only thing they need to adjust if they want to is perhaps some of the settings to begin with. And the power of this is that there's some reproducibility behind it. If they want to go back, change the data, update it next year with new species lists, update it next year with new climate projections, that's all available to them. We're giving them the power to run the model, not just the model results. The other thing is this concept of different scenarios. So not just giving them a single option. The software that we've created helps kind of manage each of these, kind of like a similar file structure, file folders. So in this case, we have 2 different species, Vesper and brewer sparrow, both available to them. They could populate that list with 100 different species if they wanted to. They could populate it with 100 different types of climates if they want to. The ability here is that we help manage all of the different model outputs. It doesn't just end up being a massive folder on your desktop with a bunch of TIFF files or a bunch of HTML files that you have to kind of manually click through. You have the capacity to go through and kind of click through each of these file explorers, rerun any specific model that you need to, or adjust any model that you need to. So the benefits of this approach is that it has a simplified management for all the different potential models you can have. Oops. You have control around the uncertainty. So we actually manage all of the uncertainty. So you do run, let's say, 100 different models. We produce for you what are the range of conditions that might result as a result of this, as opposed to you going back and having to calculate that on your own. And it's certainly efficient both computationally. We allow for spatial multi-core processing. It's done usually through C#, so it has some efficiency gains over using it straight out in R or Python, but also labor, because now if someone wants to rerun the model, instead of trying to fire up R and kind of tweak the code to load new rasters, deal with libraries being out of date and having to re-update them or whatever the other problems are, you can just fire up this program, change whatever you need to change through the GUI, and then click run, and then it's off. You're good to go. So it's credible. We use pre-existing models. We're not really coming up so much with our own. We're using common species distribution models. We're any other types of thing like connectivity analysis. We're using what's popular in the literature, what has supports. It's reliable in terms of it can be easily updated. It's deliverable in terms of it being not static. It can be adjusted. The one thing that we haven't quite cracked, and that's the big nut, is that this is still really in the realm of an analyst or a research scientist. Decision maker is not going to fire up the software, run a maxent model, necessarily understand from the probability distribution where does their conservation effort need to be applied. We can potentially do something like that by creating another report or some other deliverable for them, but it's still kind of an ongoing process of trying to get that at that accessibility, which is really probably the hardest thing I think now, at least for us, to try and accomplish, because trying to communicate that information without dumbing down the science is quite challenging. One way that we've been trying to do that is by building a a web application that's a little bit more, let's just say, intuitive, because everyone likes having web applications these days. So if you can imagine, this is one that we are currently working on, hoping to have released for September, where you have different species distribution models all available to you kind of on the web, where you can share it either with the public if they go to some URL. We actually have a URL active at cloud.synchrosim.com, so you can actually see some of these on your own. You can look up different types of scenarios, all listed here. So here I have 2 different climate scenarios and 2 different modeling types, so maxent and random forest. And then from there, you can kind of go through and click through different types of probability distributions. So having this kind of web version where you can kind of click through different time steps, see the changes happening in real time, not having to actually run the models. In this case, it's less of a model that can be reproduced. It's more static. Or let's say more of a dashboard where you can kind of adjust things. But it's more or less static in that you can't change it too much, and hopefully try and communicate a little bit easier to someone in the decision-making process, how they can kind of visually see things change throughout time. And maybe that might kind of communicate something a little bit more practically as opposed to actually giving them the model to run from the start. Bit of an ongoing process, still coming along, but that's kind of where we're at. And then from there, you can be able to project things that might happen in the future. So let's say the area of species change as a result of these different climate circulation models. So that's us. Again, it's unfortunate Colin couldn't be here, but he sends his apologies. My name's Alex. I'm going to be sticking around for the rest of the day if you have more questions for me. You can check out our website if you want. Our company website is apex.com, and also our website synchrosim.com. But if there's any questions now, I can field them now too. Thanks.